Hi. Today we are working on Unit 6, Day 7 notes. This is apply the sine and cosine ratios. So with this one, we're going to jump in with just a few different types of different trigonometric functions. We've talked about tangent, so today we're going to add on sine and cosine. Before we begin, a few things to note. We are going to need a calculator to be able to do some of the things that we're working on today. So just kind of keep that in mind as we move forward. One of the things that I want to talk about is just the review of tangent. Tangent, remember we did the opposite, and I'm going to abbreviate that OPP, over adjacent, and that was ADJ. So sine and cosine add a few different things. One of the things you notice is that we don't have the hypotenuse that we're talking about. So that's the hypotenuse is the one right across from the right angle. Sine and cosine both use hypotenuse. Sine uses opposite over hypotenuse. So sine of angle A is equal to opposite over hypotenuse. And then cosine of angle A is adjacent over hypotenuse. So just one thing to note, notice that I'm using each of these sides in each of these different three trigonometric functions. We're using them twice. We're using opposite twice, we're using adjacent twice, and we're using hypotenuse twice. Unless told otherwise, we should find the values of trigonometric ratios to 4 decimal places and then length to 1 decimal place. So one of the techniques to remember kind of the order for everything is SOHCAHTOA. And SOHCAHTOA represents so is sine is opposite over hypotenuse. I'm going to try and make it just a little bit clearer. Let's see if that'll help. There we go. And then so sine is equal to opposite over hypotenuse. So if we're talking about this is our reference angle here, if this is a reference angle, opposite would be here. And hypotenuse, of course, is across from the right angle. We've talked about that a lot. Cosine, or cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. So if this is our reference angle, then adjacent is down here. Adjacent hypotenuse is here. So those would be the two sides that we would use to find that. And then tangent, TOA, is opposite over adjacent. So tangent is opposite over adjacent. So if this is my angle and I'm finding tangent of that angle, I would find opposite over adjacent. So we're going to use those to find the values. This one we're going to do sine of R and sine of S. It says write each answer as a fraction and as a decimal. So remember sine from the previous page, SOHCAHTOA. So that's going to be opposite over hypotenuse. And this is just from the previous page. You can flip back to verify. So we're talking about sine of R. So if I use R as the reference angle, opposite of R, so if I go opposite of R, that gives me 15. And then hypotenuse is 25. Always reduce if you can. 5 goes into both 15 and 25. So if I reduce that down, that gives me 3/5. And then if I divide that in my calculator, take 3 divided by 5, you get 0.6. It says round to 4. In this case, it's exact, so we would stop here. Sine of S, so again, starting in S, opposite of S is 20. And then hypotenuse is 25. That reduces down to 4/5. And then 4 divided by 5 is 0.8. Again, we only approximate if it comes out to be a number that continues on past those 4 decimal places. Sine of R on number 2. So if I start here, opposite of this is 24. And then hypotenuse is 26. So here, this is where I would grab my calculator. Take 24 divided by 26. Oh, sorry, let's go ahead and reduce first. Both of those, let's see, 2 goes into both of those. That gives me 12, 13. 13ths. Now I approximate, and that gives me about 0.9231. And then sine of s, if I start at s, opposite is 10 over hypotenuse is 26. 2 goes into both of those, 5, and then 13 times. And then 5/13 is approximately 0.3. Oh, my answer is smudged on my original document. I'm going to divide this out. 8. Good thing I divided that out. Looks like I don't know, it looks like a letter. 3.846. Yep. All right, there we go. It's definitely not a letter. That's number 2. Number 3, what we're doing is now we're looking at sine of r first. So sine of r opposite is 16 over hypotenuse is 34. Let's see, 2 goes into both of those. Let's see, that's going to be 8 over 17. And then if I divide 8/17, I get about 0.4706. And then sine of s is equal to opposite, so 30 over 34. Both of those can be divided by 2. Let's see, that gives me 15/17, which is approximately 0.8824. That's sine. And notice I'm saying sine. It's sin to call it sin when it's really sine. So this is sine. It's actually an abbreviation. It's a very silly abbreviation, but it's abbreviation from sine. It's abbreviation 3 letters because of programming a long time ago. So that's why it's abbreviated that way. Kind of silly, but that is what it is. Example B, find cosine of A and cosine of B. And again, we're going to write it as fractions and then also as decimals. Cosine is ka, so ka, toa. So this is going to be adjacent over hypotenuse. So if I do cosine of angle A, so adjacent over hypotenuse, that's 48 over 52. 4 goes into both of those. I don't know if there's any other number larger than that. I know 4 for certain. So 48 is 12, and then 13ths. So 12/13, and then 12/13 is approximately 0.9231. And then cosine of B, so again adjacent. So adjacent is the length of 20 over the hypotenuse, which is 52. 4 goes into both of those, 5/13 times. And then that's approximately 0.3846. Cosine of A on number 5, so adjacent. So this is going to be 12. Over hypotenuse is 37. If I divide that out, I get approximately 0.3243. Cosine of B adjacent is 35. Hypotenuse is 37. If I divide that out, I get 0.9459. Number 6. So again, cosine of A. Adjacent is 24. Hypotenuse is 30. Let's see, 6 goes into both of those. So that would be 4/5. And that's 0.8. Cosine of B. Adjacent is 18. Hypotenuse is 30. 6 goes into both of those. 3, and then 5. And that would give me 0.6. Notice that we don't continue on the decimal places, like I don't fill in zeros. That's only if we need to round. Notice I also marked approximately if we had to round, and then equal to if it's exact. I'm going to finish out the rest of this page here. It says use the cosine or sine ratio to find the value of each variable. So for this one, we're actually given angle measurements. So we're going to have to use some relationship to find the value of A and to find the value of B. You can't use something that has both variables in it. So I'm going to purposely pick the wrong one first for this one to show you how you don't obtain an answer. So if you've got both the variables, it doesn't work. So it tells you to use cosine or sine. If I pick cosine first for this one, I won't get the right answer. If I pick cosine of 57 degrees, then that's adjacent. So that's A over hypotenuse B. So here I'm left with both variables. That doesn't help. I can't use that to find the answer. What I can do though is I can use sine. So the order here on this one, we actually want to use sine first. So sine of 57 degrees is equal to opposite. So we know opposite 14 over hypotenuse, which is B. So what we want to do is we want to manipulate this so that B is in the numerator. So we're going to multiply B on both sides. So we get B times sine of 57 degrees is equal to 14. Here we can divide by sine of 57 degrees on both sides. On this side, need to put my degree symbol. And then on this side, sine of 57 degrees. These cancel. So B equals 14 sine of 57 degrees. So I plug that in my calculator. 14 divided by sine of 57 degrees. And I get B is approximately equal to 16.7. Remember, this is a length, so we're going to round. So B is 16.7. Now we can use what we know here to find cosine of 57 degrees. To find what A is, because we know what B is. So using cosine of 57 degrees, it equals A over 16.7. So if I multiply 16.7 on both sides, running out of room. So 16.7 times cosine of 57 degrees is equal to A. So 16.7 times cosine of 57, and I get 9.1. So A is equal to approximately 9.1. So that's that one and that one. So for 8, looking at my variable, I want to use something that's opposite first. So we're going to use the one that has opposite in it between sine and cosine. Sine has opposite in it. So we're going to use sine of 41 degrees is equal to opposite, so 17 over hypotenuse, which is D. We want to get D in the numerator. So just like we did on the other side, we're going to multiply by D on both sides. Multiply by D, multiply by D. So that's going to give me, running out of room, D times sine of 41 degrees is equal to 17. So now if I divide by 41, sine of 41 degrees on both sides, then we're left. Oh, try to make it better, and I think I ended up making it worse. There we go. Divide by sine of 41 degrees on both sides. So we get D is equal to 17 divided by sine of 41 degrees. So if I take 17 divided by sine of 41 degrees, I get 25.9. 25.9. So now I can use cosine of 41 degrees is equal to adjacent over hypotenuse. But we know hypotenuse, that 41 degrees, or sorry, that D is really 25.9. So if I multiply 25.9 on both sides, then I get 25.9 times cosine of 41 degrees is equal to C. 25.9 times cosine of 41 is equal to, so C is approximately equal to 19.5. There we go. Next video, we'll have the next page. Have a great day. Bye.